Hello, space fans, and welcome back to G Fun Facts Online. Today, we're looking up, way up, and talking about something that's becoming a bigger and bigger deal. Stuff falling from space. Not aliens, not asteroids, but our very own satellites and rocket parts, making an uncontrolled fiery dive back to Earth. Sounds like sci-fi, right? But it's a real and growing concern. Think about it. We're launching more objects into orbit than ever before, and what goes up must eventually come down. The problem is, when these objects make an uncontrolled re-entry, predicting exactly when and where they'll hit is super tricky. While the chances of a piece of space junk landing on your head are incredibly tiny, seriously, you're far more likely to be struck by lightning. The sheer number of these events means the overall risk to people and our infrastructure on the ground is on the rise. So how do we even begin to keep an eye on this potential cosmic rain? Well, major space agencies like NASA, the European Space Agency, ESA, and France's CNES are on the case. They've got sophisticated tools with cool names like ORSAT, DAS, Scarab, Drama, and Stella. These systems are designed to do a few key things. First, they keep massive catalogs of space objects and track their re-entry events. Second, they try to predict how long an object will stay in orbit and map out its likely re-entry path. Third, they model how a spacecraft might break apart as it burns through the atmosphere, and where the surviving bits might scatter. And finally, they assess the probability of any of that debris hitting populated areas. These predictions rely on a ton of data, orbital details, atmospheric models, and info about the object itself. But here's the kicker. Our atmosphere is a chaotic place. Solar activity, atmospheric conditions, even how the object is tumbling and what it's made of, can throw predictions off. Even just a few days before re-entry, the uncertainty window for when it will come down can be several hours. And that translates to thousands of kilometers in terms of where it might land. Imagine trying to plan for that. But science always looks for new solutions, and there's a fascinating new approach gaining traction, using seismometers. Yes, the same instruments that detect earthquakes. How cool is that? Here's the science. When a piece of space debris screams through the atmosphere at hypersonic speeds, it creates powerful shock waves. Basically, a sonic boom. These sonic booms travel down to the ground and can be picked up by sensitive seismometers. By having a network of these seismometers, and analyzing when and how strongly they detect these signals, scientists can actually reconstruct the trajectory of the debris as it plummeted through the atmosphere. This isn't just theory, it worked. For example, in April 2024, seismometers across the Los Angeles basin detected the sonic booms from a re-entering Chinese Shenzhou 15 spacecraft module, allowing a team to map its path. This seismic method is a fantastic complement to traditional radar and optical tracking, especially over remote areas or oceans where we don't have many other sensors. Of course, listening for falling space junk with seismometers isn't without its own set of challenges. Our atmosphere, as we said, is always changing, with winds and weather affecting how sound and shock waves travel. This can mess with the precision of trajectory reconstruction. Also, we often don't know the exact size, shape, or how an object will fragment, which adds more uncertainty. For this method to help warn people, the seismic data needs to be processed super fast. And then there's the re-entry itself. The intense heat can create a plasma sheath around the object, causing a communication blackout, so we lose any real-time data from the object in its final moments. Plus, scientists need to be sure they're hearing a falling satellite and not a meteor or a big explosion on the ground. So why is all this monitoring becoming so critical? Well, hundreds of tracked objects re-enter our atmosphere every year, and a big chunk of those are uncontrolled. Think about famous past re-entries, like Skylab in 1979, Salyut 7 in 1991, and more recently, ESA's ERS-2 satellite in February 2024. Each one serves as a reminder that we need to be vigilant. While your personal risk is extremely low, the collective risk to our global population and important infrastructure is growing simply because there's more stuff up there to come down. Looking ahead, the future of monitoring these uncontrolled descents is all about getting smarter and working together. We're talking about developing much better atmospheric models to predict how those shock waves travel. expanding our global networks of seismometers and other sensors, and making sure all that data can be shared and integrated effectively. Harnessing the power of artificial intelligence and machine learning to sift through massive datasets and spot patterns, improving prediction accuracy. Scientists are even thinking about onboard monitoring systems for smaller satellites, like CubeSats, that could gather vital data on how things break up and what the atmosphere is like during re-entry. And crucially, this has to be a global effort. International cooperation, like through the Interagency Space Debris Coordination Committee, IADC, is key for sharing data, research, and developing common standards to mitigate these risks. In conclusion, keeping tabs on uncontrolled satellite re-entries is a rapidly evolving field. While our traditional methods give us a good foundation, innovative techniques like seismic tracking are opening up exciting new ways to detect and analyze these events. There are definitely hurdles to overcome, from atmospheric unpredictability to data processing speed. But as we continue to explore and utilize space, improving our ability to monitor and manage the risks from objects returning to Earth is more important than ever. That's all the time we have for today on Fun Facts Online. Thanks for tuning in, and as always, stay curious.